So I'm trying to explain how to use oxidation rules to find the oxidation numbers. And so we're going to do quite a few examples. So here's an ionic compound, calcium chloride. And we're going to be looking at rule 2. The charge of any ion is equal to the oxidation number. So since I know that the charge of calcium is plus 2 because it's in group 2, then that's its oxidation number. And again, I know that chloride is a minus 1 because of it being in group 17. So the oxidation number of calcium is plus 2 and the oxidation number of chlorine is minus 1. If we look at carbon dioxide and go through the rules, first we know that the sum of all the oxidation numbers of a molecule or a polyatomic is going to be equal to whatever that charge is. And for a neutral compound, 0 is the total overall charge. And we have to remember that. Then we look down the list. I doesn't have anything that says that carbon is a certain oxidation number, but if we go down to number 6, it says oxidation has an oxidation number of minus 2. Can be different, but in this case it doesn't say anything about hydrogen or fluorine. We don't have those. So minus 2 is going to be assigned to oxygen, and since there are 2 oxygens, I multiply that by 2 and I get a total of 4. So remember, this has to be a neutral compound. So if the oxygen is minus 4, then the carbon must be plus 4. So that's how we find the oxidation number of the carbon. And when we are assigning oxidation numbers, we're looking at the individual oxidation numbers for the elements. So carbon's plus 4 and oxygen is minus 2. Now here's another example, sulfur sulfate, SO4 2-. Again, we're using rules 3 and 6, and we can assign oxygen as minus 2, and there's 4 oxygens, so I have a total of minus 8 for the oxygen side, and the total oxidation number must equal to minus 2, which is the overall charge. So the oxidation number for sulfur must be plus 6. So from that math, we have the oxidation number of sulfur plus 6, and for oxygen minus. Okay, here's another example, H2O2, and this is going to use a few different rules. Well, the same rule for 3. The neutral compound, so the total oxidation number must be 0. But if I look through this carefully, hydrogen comes before oxygen, so I'm going to assign hydrogen first from rule 5. So each hydrogen is going to be 1, and there are 2 of them, so I multiply that by 2, and I get 2 overall for the hydrogen side. And because the oxygen, its oxidation number must equal to whatever should be on that side, minus 2. So all the oxygen, the total oxidation number must be minus 2. And since there are 2 of them, I take that total overall minus charge and I divide it by the number of oxygens. So actually the oxidation of oxygen is minus 1. So this is a case here where oxygen has a different oxidation number, so like in H2O2. So just to show you how the hierarchy and the rules work, I have to do 5 before I have to do 6. Here is a more complicated example of working out an ionic compound with a polyatomic. This first part is straightforward. I know that nitrate is minus 1 and there are 2 of them, so I have a total overall charge of minus 2 for the nitrate, and of course the oxidation number has to be equal to 0 because it's neutral, and so the iron must be plus 2. We knew that from making compounds in chapter 3 or 2. And so my oxidation number for iron is plus 2. I'm going to work out the nitrate separately. I have the oxygen being minus 2 from rule 6, and there are 3 oxygens, so that's a total of minus 6. But minus 6 plus something else must equal to minus 1, and so the number for nitrogen must be plus 5, so that the total overall oxidation number is minus 1 for nitrate. So I labeled it as this: nitrogen is plus 5, oxygen is minus 2.